15, okay? So we start with the number 15. Can 9 and 6 go into that? All right, the next one would be 30. Would that work? All right, the next one would be 45. Would that work? Yes, because 6 can't go into 45, right? What's the next one? Can that work?
No.
Can 9 go into 60 evenly?
No.
Nope. All right, so 15 times 5 would be
75.
75. Would that work? 15 times 6?
90.
Would 90 work?
Yes. Yeah.
Okay, make sure. Can 6 go into 90? How many times?
15.
Good. So 90 would be our coefficient, correct? Any questions about how we got that part? Now let's look at the letters. So we have x, x squared, and x. Which one has the biggest exponent out of that? And can x go into x squared evenly? Yes. Does that make sense? Okay, so it would be x squared. What about y? Which one has the largest exponent? Good. And can y go into y to the fourth evenly? Can we multiply this by something to get y to the fourth? Let me go back. We can multiply this y by what to get y to the fourth? Let me go back. 6xy, we need this to have a y to the fourth. We would need to multiply this by, go ahead CJ, y to the third, right? So that way we can multiply and it would be 6xy to the fourth. Everybody see that? Is there anything we could multiply 15x squared by to have a y to the fourth in it? Y to the fourth. Good. So we can agree that all of these have a y that can go into y to the fourth, correct? So that's our least common multiple. 90x squared y to the fourth. So the exponents, the letters are pretty easy. You just take the highest exponent. That's all you have to do. Just like we took the highest number for the coefficient. The 90x squared y to the fourth is the least common multiple. The whole thing. It's one term. Any questions on that one? We're going to skip straight down to number 3 because it's just like it, and then we'll do 2 and 4 together. All right, so my coefficients are 12, 15, and 8. What's the biggest one? Okay, so can all of those go into 15? The next one would be 30. Would that work? The next one would be, would that work? Nope. What about, the next one would be what? 60? Would that work? Alright, so what's the next one? What's 15 times 6? 75. Would 75 work? Alright, so what's 15 times 7? What's 15 times 6? I think we already checked that one, didn't we? Would 90 work? Nope. Alright, what's 15 times 7? 105. Alright, would 105 work? 15 times 8? 120. And it does work because everything can go into 120. Very good. Do y'all know what prime numbers are? What are prime numbers?
7.
7's 1.
Isn't that a number that only has 2 factors?
Yes, 1 in itself. So give me some more prime numbers. 5, 11, 2, 3, 7. Good. Alright, so I could show y'all a shortcut. I don't know if it's a shortcut to find the LCM. We'll look at it after this. Okay. Alright, so we found our common coefficient. So now we look at our A's. Which one has the biggest coefficient? Good. So that would be in our LCM, A squared. Again, because it has the highest what? Exponent. Alright, and then it would be B to the, good, C to the, very good. That's it.
You don't do anything, you just pluck the biggest one.
Yep. That way all of these can go into this evenly. Nope, that always works. Alright, so now we have number 2. And it looks kind of tricky. What can we do probably to make this easier? add. These are two separate terms. So we're trying to find the LCM of this and this. You can't find an LCM unless you have two things to compare. Let's go ahead and factor both of them. See if that works. And what I mean by factor, how would we factor this one? Pull out a y what? Squared. Good. They all have y squared in common. So if I pulled out a y squared, what would I have in my parentheses? Y squared plus 8y plus 15. Very good. And now can I factor this right here? Do I need to go back? Does everybody understand why we pulled out y squared? Alright, they had y squared in common. Does everybody know where we got this from? Yes? Okay. So we can factor this down even more. We can find factors of what? Of 15 that add together to give us 8. That's going to be what? Good. So how can I rewrite this, John? Not plus, just times. Go ahead. And perfect. Now is it factored all the way? Yes. Alright, now let's factor this one. What are my factors of negative 40 that can give me negative 3 if I add them? What are my factors of negative 40?
8 and 5.
Okay, 8 and 5. Which one's got to be negative? Good. So tell me how to write this one. Go ahead.
Y minus 8, y plus 5.
Very good. Now the factoring ones like this are really easy also. Because all you have to do is just include everything. So for example, our LCM, we'd have to have a y squared. They already have a y plus 5 in common, correct? We can bring that down, bring down the y plus 3, and the y minus 8. You just include everything. That means that this could divide into this evenly, and also this could divide into this evenly. Any questions on that one? Alright, next one, again, we have to factor. We can start with this one first. Tell me how you would go about factoring it. Good, you can pull out the 4, right? And what would I have left over inside? Perfect. And can't we factor this? Yes. What are factors of negative 4 that can give me negative 3 when I add them?
Negative 1. Or no, 1 and negative 4.
Good. Any questions so far? Alright, what about the other one? Very good. If I pull out an A, what would I have on the inside?
A squared
Minus.
9A.
Good. Plus.
20.
Very good. And how could I factor this one?
Negative 4 and negative 5.
Very good. A minus 4, A minus 5. So for my LCM, I just include one of everything. And I can start with this 4 and this A, combining them since they're out front. So I could write, what? 4A times, what will I need? A plus 1, A minus 4, and A minus 5. That's it. So that was just finding the LCM. So on your study guide, I think there's 2 questions just like this. Alright, any questions about finding the LCM or what it is? Okay. Next is dealing with simplifying rational expressions. Alright, let's go back to when we add fractions. How can we add fractions? They need to have what? Same denominator. That's why we've been finding the LCM. Okay? So to find the common denominator, we have to find their least common multiple and then change the denominators. Okay, so if we look at just the denominators, that's all we need to change, right? Look at our coefficients. What's the biggest number? Will that work? Alright, so we'll have 10. This is LCM. A to the what? And B to the? Good. Any questions about the LCM?
Can you just like run through that one?
Yes. So I looked at my coefficients, 10 and 5. What's the number that these both can go into? They can both go into 10 evenly. And what is something that A cubed and A can go into? They can both go into A cubed. And trick for that, you just keep the biggest exponent. Same thing here, you just keep the biggest exponent, B squared.
Then you didn't do anything to numerator?
Nope, not yet. So I need to make both denominators be 10A cubed B squared. Okay? So for this specific one, that means I need to multiply this bottom by what?
2.
Times 2. I'm just going to write what I'm doing first. Well, I need to change the A cubed? No, it's already A cubed. Well, I need to change the B squared? No, it's already B squared. So all I need to do is multiply this entire thing by what? 2. Let's go ahead and do that. So the top will become what? 8. The bottom? 10. What else? A cubed B squared, right? And why did I multiply by 2? Good. So I need to multiply this one. I'm just going to put my operation right here. Is it already 10? Yes, but I need to multiply this by what to get A cubed? Good. And times what? B. Good. Any questions about that part? So the top, I need to multiply by A squared and B. So tell me what that would turn out to be. 9. A squared. B. C. Good. Over. Perfect. Now they have the same denominator, correct? So now I can add them. So the top part right here, could I add 8 and 9A squared BC? Why?
It's the same.
Good. They're not the same, not coefficient. They don't have the same variables. Good. So I would leave on top 8 plus 9A squared BC, and on bottom I could put what?
10A squared or 10A cubed.
B squared. Very good. Alright, could I simplify like these A's right here? Or the B's? Why? But I subtract the exponents when I divide, right? So could I just take or simplify the A's right here? Why couldn't I though? Anybody know?
Because the 8 is added, like,
Correct. Correct, because the 8 does not have an A or a B or a C, right? If both of these had A, B's, and C's, we could simplify. But since this 8 does not, and it's attached to this 9A squared BC, we can leave it like this. Couldn't do anything else. So both terms have to have the variables in order for us to simplify. Any questions on that one? Alright, next one, we have to find the LCM of the denominators. And what would make it easier on us? We got to do what first? Got to factor. We can factor this one first. It's pretty easy. How do we factor 5x plus 10? Excuse me. Good. Perfect. And then this one, if we factor, what are factors of negative 6 that could add together to get negative 1? Very good. So our LCM, let's write this over here first. And remember, when we factor it, we keep one of everything. So tell me what the LCM is going to be. Alright, 5x minus 3. That's it. So this is going to be our common denominator. So if we look at this denominator, what's the only thing it's missing from our LCM? What's the difference between these two? It's missing the 5, right? It's already got the x minus 3, already got the x plus 2. We just need this to have what? 5. So we're multiplying this entire thing by what? 5. So what would the top look like? Perfect. Over? Perfect. Any questions about what I did there? Or how I got the 5? Okay. So now if we're looking at this denominator, the 5x plus 2 compared to our LCM, what's it missing? The x minus 3. So what do I need to do with that? Everything by? Good. So what would the top be? I'm going to put this, bring down this minus sign. What would I have if I did 4 times x minus 3? Perfect. Over? Perfect. Alright, I'm going to stop there and let y'all copy down and let me know if you have any questions so far. Alright, so everybody good so far? Okay, so on top right here, what could I combine? The like terms, right? Let's go ahead and write this all together. We have 5x minus 5. Now this minus sign is going to change both of these to what? Negative 4x and good. All over the same denominator.
So why can't you do 5x like minus 4x?
You can. We're about to.
Okay.
I just wanted to write it all out in case somebody needed me to write it out. So now we can do 5x minus 4x. That's going to be what? And then negative 5 plus 12? All over 5, x minus 3, x plus 2. And from here we see that we can't simplify anything because these are together and so is this. So we can just leave it. Any questions on this one? Yes.
Give you like a math.
Yes.
Can you explain how you got x minus 3 and x plus 3?
Right here? Yeah, we factored. So we found factors of negative 6 that could add together get negative 1. So negative 3 times 2 would give us negative 6, and then negative 3 plus 2 would give us that negative 1. Any other questions? There's also a website you can go on, and it's like a rational, I don't know what I call it, rational expression calculator, where you can type these in to check your answer. It won't show you like all the work. It'll just show you the final answer. So I'm going to share that with y'all on Google Classroom, so that way when you're working on your study guide, you can check your answer on this website. It doesn't show you how to do it. It just shows you the final answer. All right, flip it over. So on number 3, looking at the denominators, could we factor those? Yes. How could we factor 3x minus 15? So it'd be 3. Good. This one would be 6 and x minus 5, correct? Is everybody good with the factoring part of it? Okay. So what would be our LCM?
6 minus 5, wouldn't it be?
6 minus 5, but we also need that 3, right? So we can multiply the coefficient, 6 times 3, which makes what? 18, and we need one of the x minus 5s. Questions about that part?
Can you why did like x minus 5 squared?
Oh, you only need one of each. Because 18 x minus 5, let me write it over here. If I divided 18 x minus 5 over 3 x minus 5 right here, right? I could divide these because these would cancel out, and 18 divided by 3 would be 6, right? But if this was 18 x minus 5, 3x minus 5 squared, these would cancel out 6, but I'd still have x minus 5 on bottom, right? So the reason it says LCM is it's the least common multiple. So both of these would work, but this one is the least. It has the smallest exponent. That's why we picked that one. Does that make sense? Just like 4 and 12, you could say that 24 is the least common multiple. That's not true. It would actually be 12, if that makes sense. Okay, so what do we need to change about this one? Good, so this needs to be 18, so we need to multiply it by? Good. So if we multiply this entire thing by 6, we'll get what on top? Good, 6x plus 60 over 18 x minus 5. Very good. Questions about that part? Okay. On this one right here, we'd have to multiply by 3. So the top would be, good, over, yes.
When you multiply 6 on both minus 5, how come it stays x minus 5?
Because I multiplied the 6 by that 3 out front. 18. Mm-hmm.
Why did you need to get, you needed, okay, never mind.
Alright, and don't forget this says minus this entire thing up here. So what's going to happen to both of these? Yeah, the signs are going to change. So let's write it all together. This is 6x plus 60. What else? Minus. Good. All over 18x minus 5. So what would I get when I combine my x's? And then my regular coefficients? Over. Could we simplify this? Okay, how could we simplify it? There's 2 different ways we could do this. The 15 and the 18, what about it? Remember, all 3 of these have to have something in common, or they all have what in common? 3. Good. So we could take out a 3 out of all of these. That would be what up top? Over. Questions about how we got that part? There's one more thing we could do. You don't have to do this. You could leave it like this on the homework quiz. But doesn't negative x plus 5 look a lot like x minus 5? The only difference is what? On both of them, right? These are different signs. These are different signs. That's all. Do you know how we could change these signs up top? Yes. We could put a negative 1 out front. And then if we bring out the negative, what would this be? X minus 5 over 6x minus 5. Now what could happen? And you would get negative 1 over 6. Isn't that cool? So cool. All the variables went away. I thought it was cool. Now, if you leave it like this on your test, I wouldn't mark it off. But I'm just showing you how it can simplify. This, yeah, I wouldn't count off. I'm not going to count off if you don't simplify. Alright, I want you to try 4 and 5 on your own, but let's just find an LCM for both of them first, then you're going to try it on your own. Because I think that's the only part y'all are really having trouble with. Alright, so to find an LCM for number 4, first we'd have to do what? Factor. Good. So, Brasida, help me out with this bottom. What are factors of 18 that could add together to get 9? Perfect. So this is x. Good. And this one we can just leave as x plus 6. So Dylan, what would be our LCM?
X plus 6.
Is that all?
X plus 3.
Very good. Any questions about that part? Alright, any questions before you start on that one on your own? Alright, go ahead and try it. Let me know if you need help, and make sure y'all help each other. Like, if you have questions, ask each other. And if you want to check your answer when you get done, just raise your hand.